Okay, so covered just in the last video how we're actually going to sample our data and what sort of SRSs we'll have. So again, I alluded to the fact that there's going to be two populations that we're comparing: the opening day pitcher versus the pitcher who pitches later in the series. That we'll end up doing a set of tests. Again, there'll be two sample t-tests, and that was, again, I think it's chapter 19, I think, or 20. I have to look, unfortunately, but that'll be primarily what we do. Now, the other thing that we're going to be doing, and this is where quality start kind of plays a role, is that we will be doing comparisons of proportions. And again, that will be the two sample test for proportions, and it's listed on your list. Two sample Z test for proportions, and also two sample Z confidence interval for proportions. Probably do both of those. And the idea there is that what we're going to be comparing is the percentage or chance of getting a quality start for one population versus the percentage chance of getting a quality start for the other population. And we're going to see if there's a significant difference between the proportions of those two populations. Again, the idea, or at least the premise that we're going on, is that the pitcher who had more rest is going to have a better chance of pitching a quality start than the opening day pitcher. Again, that's what we'll test. Okay, there's one more test that I think we're going to want to do, and that is something of, let's see if I actually wrote down what it's called, because I remember looking in the book. In fact, let me see if I can get that. Well, you know, I don't want to take too much time in getting this, but what we're going to end up doing is something interesting called a matched pair population comparison. And it's one of the, I'm going to see if I can quickly find it. It's very, very late in the book, chapter 20 some odd. Fudge. I'm not sure if I'll be able to get it. I think it's chapter 24 early. There it is. No, that's regression. True. Yeah, okay, without chewing up. No, come on, we'll give one more try here. Yeah, okay, never mind. Save it. It's an interesting test where we're comparing two populations. But what we're looking to do is see if there's a correlation, a strong correlation. By the way, this idea I'm going to probably have to record this separately. So this is now, we'll consider this an overview. But what I want to see is whether or not the percentage chance of pitching a quality start correlates well with the team winning the game. And this is kind of a tricky one, because what we're going to end up doing is we're going to for the pitchers that pitched a quality start, we're going to say what was the chances of the team winning the game. And for the pitchers that didn't pitch a quality start, what was the percentage chance of winning the game? And that will certainly correlate well. That when the pitcher pitches a quality start, the chances of winning are much higher. What I'm curious about measuring here is to see if there are different ways of stating that a quality start was attained by a pitcher, different rules, if you will. And I think with different rules, the correlation between quality start and winning will be much higher. This might involve regression, and in some ways I'm thinking this is maybe a little bit too much. You know, at some point we don't want to like solve every possible baseball problem in the world here in this paper, right? So this could be outside of the scope. But what's interesting is that we might be able to use regression, and remember your professor said try to use regression, and so this is the best idea that I've come up with in terms of how we might use regression. But more on this later. Sorry, I know I was a little bit rambling there, so I'll cover that one later. So kind of in summary then, going back to your outline here, the test that you want to pick, again, I think the SRS that I described in the previous video will give me an idea of what we're sampling. But the kind of tests we're going to be doing are these two population comparisons of means, which we'll compare the ERA differences from the two populations. We'll compare the WHIP populations from the WHIP means of the two populations. Those are the two numerical ones. And then we'll also compare the proportion of quality starts between the two populations. And again, we might do something else that I was rambling about. That's probably enough, or at least enough to get started. We'll talk more about it when we talk next on Sunday. But this is kind of the basic ideas, I think, of the kind of tests that we want to run. Now, just to see if I can finish here, your report should analyze the data graphically, right? So graphically, we'll end up plotting our the samples we take. We'll plot the WIP and we'll plot the ERA in both of these samples, both the opening day picture and the later picture. What's going to be interesting there is I think that's where you'll see that the distribution of particularly in the ERA case, is not normal. But the distribution of the WIP, I bet, looks pretty normal. So we'll plot that, and we'll do a histogram or a stem plot or both to get an idea of what the data kind of looks like. That's that. Now again, the summary statistics, we'll end up doing confidence intervals and significance tests of both of these to say, for example, one of the claims might be the opening day picture has a WIP that with a mean of 1.7 and a plus or minus 0.2 or something like that. But the later pictures have a WIP of 1.4 plus or minus 0.15 or something along those lines, right? So that's a confidence interval. That's the mean plus or minus is a confidence interval. We'll probably also do a significance test that says, are these two means significantly different? And that, remember, that's the we'll do the H sub 0 and the H sub A, where H sub 0 essentially says that the WIPs don't vary much between the pictures, and H sub A will say that the WIP should be better or higher for the opening day picture, meaning the picture pitches worse. And so we'll end up doing those significance tests as well. I'm sorry, the confidence. The significance test as well as the confidence intervals. And we'll do the exact same thing when we compare the proportion of quality starts. That's probably about it. Okay, I'm going to stop here.